In this video, we are going to explore Python context managers and how they can help you write cleaner and more efficient code. We'll be focusing on how the with statement can simplify file handling and resource management in your Python programs. So, what exactly are context managers? A context manager is a protocol that allows you to allocate and release resources precisely when you want to. They are implemented using the with statement in Python and designed for proper resource management. Key benefits of using context managers include: it guarantees proper cleanup of resources, simplifies error handling, makes the code cleaner and more readable, and helps avoid resource leaks. Let's examine the traditional way of handling files. In the code shown, we use a try finally block to ensure that the file is closed, even if an error occurs. First, the file is opened in the try block, then the content is read and processed, and finally in the finally block the file is closed. If an exception occurs between opening and closing the file, we need to handle it explicitly with try finally blocks. This can lead to verbose and less readable code. Now let's look at the modern way of file handling using a context manager with the with statement. Here we open the file using the open function with the with statement, which automatically assigns the file object to the variable file. Within the with block, we read and process the file content. The file is automatically closed when the code block exits, even if an exception occurs. This makes the code cleaner and more reliable. Let's understand how context managers work behind the scenes. They rely on two magic methods: ___enter__, and ___exit___. The ___enter___ method is called when entering the with block, and the ___exit___ method is called when exiting the with block. Importantly, the ___exit___ method is called even if an exception occurs. These methods handle resource setup and cleanup automatically. First, the with open is called. Then the ___enter___ method runs and the file is opened. Next, the code inside the with block runs. Finally, the ___exit___ method runs and the file is closed. Now let's see how we can write our own custom context managers. We define a class called myFileManager with an initialization method that takes the file name and mode as arguments. The ___enter___ method opens the file and returns the file object. The ___exit___ method closes the file. The ___exit___ method receives information about any exception that occurred, allowing for error handling. By defining these two methods, we can create our own context managers for any resource that needs careful handling. Now let's put our custom context manager to use. We use the myFileManager class with the with statement, passing the file name and mode. Inside the with block, we read and print the content of the file. The ___enter___ method is called when entering the with block. The file is opened and returned for use in the block. After the block completes, the ___exit___ method is called, and the file is automatically closed, even if exceptions occur. Let's discuss about contextlib module. We import the context manager decorator from the contextlib module. We define a function called file_manager that takes the file name and mode as arguments. Inside the function, we use a try finally block to ensure that the file is closed, even if an error occurs. We use the yield keyword to return the file object. Using the decorator-based context manager, we open the file using the file_manager function with the with statement, which automatically assigns the file object to the variable file. Within the with block, we read and process the file content. The @contextManager decorator lets you create context managers using generator functions with yield. Context managers are not limited to file handling. Let's explore some real-world examples. Context managers can be used to automatically close database connections after use. This ensures that connections are properly released, preventing resource leaks. Context managers can also be used for managing thread synchronization using locks. This helps prevent race conditions and ensures that shared resources are accessed safely. They can be used for creating and cleaning up temporary files. This ensures that temporary files are automatically removed, preventing disk space issues. Context managers can be used for measuring execution time. The code block's execution time will be measured with a timer. To make the most out of context managers, here are some best practices to keep in mind. Each context manager should have a single clear purpose. Design context managers to handle one specific resource or state, and use composition to combine multiple context managers when needed. Create context managers that can be reused across multiple projects by parameterizing them appropriately to make them flexible. Package common context managers into utility modules. Ensure your context managers handle exceptions properly. The __exit___ method should decide whether to suppress exceptions by returning true from __exit__ to suppress exceptions or false to propagate them. Clearly document what resources your context manager acquires and releases, including examples of usage in doc strings. Specify any side effects or changes to system state. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.